Hello everyone. Today we're going to review the law of sines again because there are these things called ambiguous cases, which actually make some of our answers a little bit more interesting. So for these particular ones, we're dealing with triangles that are side-side angle. So remember that that means from geometry that we have two sides and the non-included angle. So for instance, on this triangle, we have these two sides here, and this angle is not in between those two sides. So when we come across a triangle like this, there might be other answers. So our options for a triangle like that, while using the law of sines, is that there's going to be no solution, there might be one solution, which we've dealt with, or there might even be two solutions. So we're going to practice this real quickly, and then you're going to work on an assignment. So let's talk no solutions. So this triangle right here has a 30-degree angle, and its two sides are 16 and 7, and the 30 is not included. And if I wanted to find the measure of angle B, with my law of sines, I would first have the sine of 30 over 7, remember because the angle and its opposite side make a ratio, and the sine of B over 16, so the angle and its opposite side. So if I were to solve for the sine of B, I'd first multiply both sides by 16, and I'd have that the sine of B equals 16 times the sine of 30 over 7. Now here's the problem. If you were to put that into your calculator and then hit that inverse sine button, you would get an error, which means that this problem does not work. There is no solution. So sometimes when you do this problem, you're going to get an error on your calculator and you didn't punch something in wrong. There's just no solution. So that is one of your options, no solution. Okay, let's talk two solutions. So sometimes there's almost like a hidden triangle that we have to find. So let's just say we have this triangle. Angle A is 30 degrees. The two sides are 16 and 10. A is not included. If I wanted to find the measure of angle B, I would have the sine of 30 over 10, angle and its opposite side, equals the sine of B over 16. I would multiply both sides by 16, and I would get that the sine of B equals 16 times the sine of 30 over 10. Now, if you put that into your calculator and then you did the inverse sine, you would get that B equals 53 degrees. And you're like, okay, I have an answer. That's awesome. But here's the problem with this triangle. If we look at this triangle, I can actually create an isosceles triangle within this triangle. I'm going to move this side over here, and I'm going to say that this is also a length of 10. So if I look at this triangle here, I know it's not drawn to scale, it is an isosceles triangle. Okay, think back to geometry. Two sides are the same, then their base angles are the same. So if I just said that this angle here is 53 degrees, then this angle is 53 degrees. So a little more geometry. That means that these two angles are supplementary. Supplementary means they add up to 180 degrees. They're on a line. So if that angle is 53 degrees, then its supplement, do 180 minus 53, is 127 degrees. Now our question is, does that actually fit into a triangle? So if I look at this obtuse triangle here, can I have a triangle that has a 30 degree and a 127 degree? Well, so far that triangle adds up to 157 degrees, which is possible. That means that we have less than 180 degrees accounted for, which means there are two possible answers for this problem because the supplement also works. So the idea of supplementary is going to be what you're looking for. So you're going to take the 53 degrees, its supplement is 127 degrees, and you're going to say, does that fit in the triangle? Since this answer is a yes, this is two solutions. I'm going to show you one now that the answer is no, its supplement does not fit, which means we only have one answer. So here's a triangle. We have 30 degrees, 16 degrees, and 20 degrees. And again, we're asked for the answer for the measure of angle B. So we have the sine of 30 over 20 equals the sine of B over 16. If I multiply both sides by 16, I get the sine of b equals 16 times the sine of 30 over 20. If I put that in my calculator and do my inverse operations, I get that b is 24 degrees. So far I know that b is 24 degrees. Now let's do the same thing we just did with the other triangle. So if I made a line go here so that I created, to the best of my ability, a isosceles triangle, that means that this is also 24 degrees. And the supplement to a 24 degrees is 156 degrees. Now we have to ask ourselves, can we have a triangle whose angles so far are 30 degrees and 156 degrees? And the answer is no, because 30 degrees and 156 degrees add up to something more than 180. So that means for this one, its supplement doesn't work because the supplement makes it too many degrees for a triangle to actually exist. So on this one, the supplement didn't work, and therefore there's only one solution. So when you're going over these problems, first, no solution means you're going to get an error in your calculator. If you don't get an error and you get an answer, you need to check, does the supplement create an obtuse triangle? So those are your three options. Your word of the day, I like this word, ambiguous. Make sure you spell it correctly. And your assignment is the law of sines, ambiguous cases. Let me know if you have any questions. Email me, Google Classroom, show up to virtual office hours. Everybody taking your AP test, good luck and have a great day.